Back in June 1999, Sean Fanning and Sean Parker launched Napster, letting anyone with an MP3 drag and drop to millions of strangers, no central server needed. But how did Napster connect all those computers directly? That question leads us to P2P's defining architecture. In a peer-to-peer network, every node is both client and server, sharing storage, bandwidth, and compute directly, no master server required. Unstructured networks like early Nutella flood queries randomly, while structured overlays use DHTs for efficient lookups. Knowing the layout, peers still need to find and connect to one another. New peers join via bootstrap servers or supernodes. They request a list of active peers, then start swapping data. Once a peer link exists, efficient routing matters. That's where routing protocols come in. Unstructured P2P searches flood the network, simple but bandwidth intensive. In Cademula, each node has a 160-bit ID. A distance is the XOR of IDs, so lookups contact only big O of log n peers. Imagine a vast digital library where each book and librarian has a unique 160-character code. To find a book, you don't search the entire library. Instead, you calculate the difference between your code and the book's code using a method called XOR. This calculation tells you which librarian is closest to the book you are seeking. You then ask that librarian, who points you to someone even closer, and so on. Remarkably, even in a library with millions of books, you can find your desired book in about 20 steps. This efficient system is how Cademula enables peer-to-peer networks to locate data swiftly and without a central server. Routing pins down where data lives, but how do peers actually swap the bytes? BitTorrent splits files into chunks and swarms them. Downloaders simultaneously upload to others, maximizing throughput. P2P scales as more peers join and resists single points of failure. But free riding, Sybil attacks, and unpredictable node churn pose security and reliability hurdles. Why P2P lost out to client-server? Compared to P2P, client-server models offer centralized oversight, making it easier to implement updates, enforce security policies, and manage resources efficiently. Central servers facilitate better monitoring and control, aiding in the prevention of malicious activities. Client-server architectures provide predictable performance and can scale effectively to meet growing user demands. Despite these advantages, P2P networks have made significant contributions to technology. Let's zoom out to the future of peer-powered networks. For one, local-first computing puts data on your device, syncing P2P only when needed, powering offline-first apps with sub-millisecond responses. And decentralized Web3 platforms promise censorship-resistant social and content networks built on P2P roots. From Napster to Bitcoin, P2P powers resilient, scalable systems. What P2P application has impressed you? Let me know in the comments. Subscribe for more such videos.